beef is so fresh, it's still mooing, and the vegetables came right from the garden.
Hi, I'm Brendan Boyle, and I'm the visitor.
Hi, I'm Eric Duberstein, and I'm the mayor.
Hi, I'm Isaiah Grove, and I'm the chief engineer.
This city is incredible. Oh, no. Sorry, sir. Please sit down. Are you the mayor?
Yeah, I'm Eric Duberstein,
Just the
mayor.
person I was looking for. I'm Brendan Boyle. I'm the inspector from the world renowned best cities in the world.
Hi, I'm Eric Duberstein, mayor of our beautiful city, Libets.
I'm here to ask you questions about this wonderful city.
Alright, let's get started.
What's your population?
Oh, the population of Libet is 105,000 people, all races and religions.
What recreational activities do you provide for your city?
Oh, in our city, we have many recreational activities, including parks, and all these are managed by recreational managers.
Mayor, I was sitting on my day off when I saw someone official walk. Oh, he's right there.
Who are you and why are you here?
I'm Brendan Boyle, and I'm here to ask you questions about Libet.
Oh, it's pronounced Libet.
Oh, and who are all those people? Are they criminals? They're just staring at us. Why are they here?
Oh, they want to hear about Libet too.
You know what? Let's just start over. I'm Isaiah Grove, and I'm the chief engineer in Libet. I know that engineers can be overshadowed sometimes, but they're actually a huge part of our city and every other one around the world. All kinds of engineers help make the city what it is today. Civil, mechanical, electrical, chemical, geotechnical, and many more.
Speaking of electrical engineers, how do you provide electricity to your city?
Oh, in our city, we provide electricity with a huge geothermal plant. Our geothermal plant sends cold water down to the mantle of the earth. It then gets superheated into steam, rushes to the surface as steam, and turns a turbine, which powers our city. The heat is also used to power buildings. Our city is also located in a prime spot to use geothermal energy.
Wow, that's really cool. What do you have for transportation?
Oh, in our city, our citizens have a very innovative transportation system. It is a standard fuel cell car, but re-engineered to recycle its emissions back into fuel. This works by using a normal fuel cell. A normal fuel cell uses hydrogen and oxygen and creates water and also electricity. The water that comes out of the fuel cell then goes through a water splitter. We redesigned a water splitter to split water without needing any further energy to operate. So then the hydrogen and oxygen goes back into the fuel cell and creates a loop of energy, which creates abundant electricity, which powers an electric car. This system is very expensive, but we mostly eliminated that problem by giving many government incentives, such as discounts and also free car washes and oil changes.
Engineers were a huge help with that. Our civil engineers designed these highways and these roads to help make it safe and smooth to drive, and our automotive engineers designed 100% of those cars.
Wow, so if I get a car in the city, I'll never have to pay for gas?
Yeah.
Incredible! I also hear that your city is a very innovative farming system. Can you please describe it?
Yeah, I'll take this one. Our farming system is located under our city. It has many sources of protein, including cows, and many vegetables, including corn. We have people working underground to harvest our vegetables and bring our proteins to the people in our city using an enormous elevator. We have an automatic sprinkling system and grow lights to help nourish our plants. The methane from the cows is collected and brought back up to use for energy. Thanks to Mayor and many engineers, this can be an efficient system. One main engineer that I would like to highlight would be geotechnical. Since our city is right on a fault, it is prone to earthquakes, and since our farms are underground, they're prone to cave-ins. One way that we fix this is our geotechnical engineers innovated a thing called isolation barriers. Isolation barriers isolate the building from the ground and protects it. And as you can see, Eric over here, exempling.
So this toothbrush is simulating an earthquake, and this sprinkler is simulating isolation barriers to see how it protects the house from the earthquake.
One bad thing about these isolation barriers, though, is it wastes resources like rubber to make it.
Also, in our city, we have a very unique energy cycle, cycle. In the top of a modern city, it's normally the sun, which provides electricity to citizens, even if it's due like coal, or and also provides the sun to grow the crops. But in ours, it's a geothermal plant, which powers our citizens' homes, as well as powering the grow lights in the underground farms, which grow crops such as wheat that go directly to citizens, as well as seeds such as corn that go to livestock, which which eventually get eaten by the citizens.
Wow, that's really cool. How does this system conserve water?
Oh, this system conserves water because the water gets sprayed from the ceiling and waters the plants. The air that is leaving the underground farm returns to the surface and then is dehumidified. That water that is captured is then re-given to the plants with the sprinkler system. It does use large amounts of energy, but it is fine because we are powering it using our geothermal plant.
I also hear a city providing type of plant. How does that work?
Oh, that works by simulating the climate in the underground farm. When air enters our farm, it is either heated or cooled by a geothermal system, and it can also be humidified to make sure the plants are nourished.
Could this city get any better? How does it work? Is there any other things that are innovative?
Yeah, we have a great way to dispose of our garbage. It takes up no room. The only thing that gets in the way is the building that helps us get rid of it. The thing that we use is called plasma gasification. Plasma gasification is somewhat similar to incineration. First, the garbage enters the cylinder and eventually leaves as syngas and scrap metal. Syngas is sort of like natural gas and can be used to produce electricity or burn to heat homes. This method of garbage disposal is efficient and clean because it turns garbage into clean burning fuel. This system is expensive because of the large amount of electricity used, but most is regained from the leftover syngas and scrap metal that we sell to neighboring cities.
Wow. Is there anything else before I go?
What?
The stadium.
Oh, I almost forgot. Our stadium is the future of multi-purpose stadiums. Under the stadium, we have our 5 fields and our mini golf course setup. You have a giant aluminum table set that goes up to the level of the field. A mechanical function then sends the field onto the table. The table then goes up to field level and locks into place to provide a safe and fun way to play sports. It also provides a roof to invite us as citizens to the sun and keep them from the rain.
Thank you, Mr. Dubersack and Mr. Bill. I love visiting your side.
Any questions?
Questions?
Yeah, I'll start out. Staring me in the face is this big yellow and orange sign that says Libets Manufacturing. What do you manufacture?
Oh, well, in that manufacturing plant, so we have part of our underground farm, like the processing plants for the grain. So this is supposed to be a silo, and then this is supposed to be the plant where the, like, say, wheat is processed or any other crops.
Okay.
No?
Well, how did you choose your city's urban agricultural design?
Well, we were originally going to do a aquaponics system, but we decided against it. So
We noticed that was just way overused.
Yeah.
And go to a lot of future cities, and you see that being used. So we wanted to have something unique.
plus that was already being used in some cities today.
Yeah, so
around
it's
the
not
world.
that like futuristic.
So it's not innovative. So, but the aquaponics system was originally going to be underground, so we just kind of changed it up a little. So we just have a normal farm underground. And since Arkansas is such a dry climate, it was kind of hard to put it overground because the plants would get very dry. But since
And require like large
Yeah.
amounts of water.
But since we have that climate control system that Eric talked about, it helps us grow any plant underground. So.
How did you make your moving part operable? I think there are 2 parts.
Yeah, the moving parts in our city this is just an electric toothbrush with the head taken off, and it moves back and forth, and then it pushes on a spot here, moves the support on the bottom, which the house is on.
And then the stadium, we just have a little circuit set up with a motor, and there's a string attached to the motor. So when we flip the switch on, the string wraps around the motor and it pulls it.
And I just was wondering, from idea, testing and so forth, is there changes in those moving parts?
Yes.
Yeah, this was actually done for a science inventory project.
Mhm. And I changed this one, I don't know, 3 or 4 times. I mean, we had a certain kind of plastic to start out with, acrylic plastic, but that cracked too much, so we had to get polycarbonate, so then we had to redo this, and we set the circuit up, and it took several trips to the store, and we just changed it a lot because it didn't work, and So,
Eventually, we got it down.
yep.
Yes.
Through the course of doing the project, what did you learn about the engineering profession that you didn't know before?
I learned that there's way more engineers than I could think of. Like, I didn't know I thought there was only the main ones, like civil, mechanical, electrical, kind of that.
Yeah,
Then
but
I
there's
learned
like very many specialized ones that don't exist today. It's really
mechanical,
technical.
structural, and automotive.
Yeah, I would say the thing for me is that geotechnical engineer. I was just doing a little research on engineers, and I learned what it was, and I thought that was pretty interesting, so we decided to incorporate it in our script.
So it looks like you guys did a great job of thinking about flow diagrams and kind of mapping everything out. Can you tell me about when you guys were doing your upfront kind of design and thinking about what your city was going to look like? What sort of tools and process did you guys try to use to think about how you were going to make your city before you actually started making it? Or did you just jump into it and started tinkering?
We just jumped right into it and started. We just took a document and wrote down all our ideas and how everything would work together.
Yeah, like, we researched like clean ways to dispose of garbage and clean transportation methods, and we figured out ways to like innovate, like fuel cell car, for example, to have an infinite fuel loop.
Yeah.
And another thing, when we were we jumped right into it and we started building our model and stuff, we did a little research on how much a city like this would cost in the future, and we were talking about it, had some conversations about it, and we decided that it's very hard, if not impossible, to tell how much a city would cost, because the economy, the jumps and the ups and downs and ups and downs that it's having right now, it'd be so hard to tell all the finance for all these buildings and
really
futuristic things that we have.
Yeah, and also the parts of our city with the underground farm. It was built. Our city was built out of a quarry, so the excavation was already done, which greatly reduced the cost of building our city.
Was the earthquake ground fault part of your guys' problem statement, or did you introduce it as your own problem that you wanted to solve?
Yeah.
That's cool.
Because like because earthquakes happen a lot, they're very disastrous. Like lots of things are destroyed, cost billions of dollars. So we wanted to figure out a way to prevent less damage, or it would cost less if it happened, stuff like that.
And why we decided to display this is because for our geothermal plant to work the most efficient, it needs to be right on top of a fault. And the trade-off of having it on a fault is that earthquakes will happen a lot. So we wanted to show how we prevent that from happening.
Is there any public transportation?
We have a bus system and a subway system that both run on the fuel cell technology, where they're clean.
We don't represent it on our model.
Yeah, on our model we decided to focus on the underground farms.
The agriculture.
Yeah.
Well, we'll take a look at it.
Yeah, that's it.
I have one more question before we do. The base stands for Landon, Isaiah, Brennan, Eric, and Tyler.
Yeah.
Where's Landon and Tyler?
They're back
Right
there.
there.
Okay.